Hello everyone, my name is Hailey J.G. Rodriguez from grade 11 STEM Courage. I'm the one who connects the wires in our Arduino activities. This video is all about Arduino, how we make the LED, buzzer, and 7-segment display work through proper wiring and programming.
And hi, I am Maritoni Viandes. My role in our group is to bring our design to life by coding the Arduino Uno.
Hi everyone, I'm James Carlos Laus from STEM 11 Courage. I'm the one who assists my group mates in encoding and fixing the actual circuit, and I also took charge of editing this video.
For Lesson 1, we explored several LED activities using the Arduino Uno. Each activity helped us understand how to control lights using programming and circuits. Let's go through each activity step by step.
The first activity is blinking an LED. In this project, the LED turns on and off at regular intervals using a simple Arduino program. The materials used are 1 Arduino Uno, 1 LED, any color, 1 220 ohm resistor, 1 breadboard, and 2 jumper wires.
Here are the steps.
Step 1. Connect the LED to a digital pin of the Arduino through the resistor. Step 2. Write a program that sets the LED pin to high for 1 second, then low for 1 second. Step 3. Upload the code and observe the LED blinking continuously.
Then you have it, blinking an LED.
The second activity is fading LED. Here we gradually increase and decrease the brightness of the LED using pulse width modulation, or PWM. This creates a fading or breathing effect.
The materials used are 1 Arduino Uno, 1 LED, 1 220 ohm resistor, 1 breadboard, and 2 jumper wires. Here are the steps. Step 1. Connect the LED to a PWM pin on the Arduino. Step 2. Use a program that adjusts the LED brightness smoothly. Step 3. Upload the code and you'll see the LED slowly fading in and out.
In Activity 3, we control 2 LEDs to blink alternately. When one LED turns on, the others turns off, and they keep switching every half seconds.
The materials used are 1 Arduino Uno, 2 LEDs, any color, 2 220 ohm resistors, 1 breadboard, and 4 jumper wires.
Here are the steps.
Step 1. Connect both LEDs to different digital pins on the Arduino. Step 2. Upload the code that alternates the signal between the two LEDs. Step 3. Once uploaded, you'll see both LEDs blinking one after another.
Next is button-controlled LED. This project shows how to use a push button to control when an LED turns on or off.
The materials used are 1 Arduino Uno, 1 LED, 1 220 ohm resistor, 1 push button, and jumper wires. Here are the steps. Step 1. Connect the LED and the push button to the Arduino. Step 2. Use a code that detects when the button is pressed. Step 3. When pressed, the LED turns on. When released, it turns off.
For Activity 5, we control the brightness of an LED using a potentiometer. The potentiometer acts like a dimmer knob. It changes the brightness depending on how much you turn it.
The materials used are 1 Arduino Uno, 1 LED, 1 220 ohm resistor, 1 potentiometer, 10K, jumper wires, and breadboard.
Here are the steps.
Step 1. Connect the potentiometer to one of the Arduino's analog input pins. Step 2. Write a program that reads the potentiometer value and adjusts the LED brightness using PWM. Step 3. Turn the potentiometer knob to see the light brightness increase or decrease.
That concludes Lesson 1, Arduino LED Activities. Through these projects, we learn how to use Arduino to control LEDs in different ways, from simple blinking, fading, and button control, to brightness adjustment. For Lesson 2, we explored buzzers. Small audio component that produce sounds when given an electrical signal. When connected to an Arduino, the buzzer receives a high or low signal that makes it produce a tone. Buzzers are commonly used in alarms, timers, and notification system in many electronic projects. In this lesson, we work on several activities and tasks that help us understand how to control and program buzzer in different ways. Our first activity is buzzer beep on button press. In this project, the buzzer produces a sound only when the button is pressed.
The materials used are Arduino Uno passive or active buzzer, push button, 10K resistor, jumper wires, and breadboard.
Here are the steps.
Step 1. Connect the buzzer and the push button to the Arduino. Step 2. Write a program that turns the buzzer on when the button is pressed and off when released. Step 3. Upload the code and test. The buzzer should beep every time you press the button.
The second activity is melody player with a buzzer. This project uses the tone function to play a simple tune using a passive buzzer.
The materials used are Arduino board, passive buzzer, jumper wires, and breadboard. Here are the steps. Step 1. Connect the passive buzzer to a digital pin on the Arduino. Step 2. Use the tone function to generate notes with different frequencies and durations. Step 3. Upload the code and listen to the melody as it plays through the buzzer.
For Activity 3, we made the buzzer produce SOS in Morse code. In Morse code, SOS is represented by ...
The materials used are Arduino board, active buzzer, jumper wires, and breadboard.
Here are the steps.
Step 1. Connect the active buzzer to the Arduino. Step 2. Write a code that makes the buzzer beep short and long tones to represent the Morse code for SOS. Step 3. Upload the program and observe as the button beeps the SOS pattern repeatedly.
Next is the light-sensitive buzzer alarm. This project uses an LDR sensor, or light-dependent resistor, that activates the buzzer when light is blocked or reduced.
Materials used are Arduino board, passive buzzer, LDR or light-dependent resistor, 10K resistor, jumper wires, and breadboard. Here are the steps. Step 1. Connect the LDR and the buzzer to the Arduino. Step 2. Program the Arduino to turn on the buzzer when the light level drops below a certain value. Step 3. When you cover the LDR, the buzzer activates automatically.
For activity 5, we control the frequency of the buzzer sound using a potentiometer. The potentiometer acts as a control knob to change the pitch of the sound.
The materials used are Arduino board, passive buzzer, 10K potentiometer, jumper wires, and breadboard.
Here are the steps.
Step 1. Connect the potentiometer and buzzer to the Arduino. Step 2. Write a program that reads the potentiometer's analog volume and maps it to a sound frequency. Step 3. Upload the code and try turning the potentiometer knob to hear different tones. That's all for Lesson 2 Buzzers. Through these activities, I learned how to control sound using Arduino. From simple beeps and melodies to light-sensitive alarms and Morse code signals.
For Lesson 3, we learn about the 7-segment display, one of the most common electronic displays used to show numbers and few letters. You can often find it in digital clocks, calculators, counters, and many other electronic devices. This lesson helps us understand how a 7-segment display works, how to connect it to an Arduino, and what kind of project we can make using it. Our first activity is displaying a single digit on a 7-segment display. In this activity, we program the Arduino to display the number 3 by turning on the correct segments.
The materials used are 1 Arduino Uno, 1 common cathode 7-segment display, 7 pieces of 200 ohm resistors, jumper wires, and breadboard.
Here are the steps.
Step 1. Connect each segment of the display to an Arduino pin through a 220 ohm resistor. Step 2. Write a program that turns on the segments corresponding to the number 3. Step 3. Upload the code to the Arduino and observe the display showing the number 3.
The second activity is displaying numbers 0 to 9 sequentially. In this project, we made the 7-segment display automatically circle through the numbers 0 to 9 in a loop.
The materials used are 1 Arduino board, 1 common cathode 7-segment display, 7 pieces of 220 ohm resistors, jumper wires, and breadboard. Here are the steps. Step 1. Connect the display to the Arduino just like in the previous activity. Step 2. Create a program that defines the segment combinations from number 0 through 9. Step 3. Use a loop to display each number one by one with a short delay between them. And lastly, Step 4. Upload and test the program. The display should count from 0 up to 9 repeatedly.
We generated the code with the help of ChatGPT by describing what materials we used and the title of our task. Then we improved the output together. And this is the flowchart to show how the custom melody program works step by step. We created a circuit diagram based on the components needed for our custom melody project. Same as the first task, we generated the code with the help of ChatGPT. This flowchart shows how the traffic light works. Our circuit diagram shows how each LED is connected to the Arduino.
For Lesson 1, we work with LEDs. One problem we faced was that some of our wires were old and the LED didn't light up at first. We tried changing the wires and LED. In Lesson 2, we used a buzzer. Same problem again. Old wires and loose connections. At first, it didn't make any sound and we thought our code was wrong. but when we fixed the wirings, it started to beep properly. For lesson 3, we work on the 7-segment display. This one was kinda hard because it has many pins, and we got confused which one goes where. Some numbers didn't show correctly at first, so we had to recheck and fix the wires again.